Good evening, everyone. Myself, Sana Sheikh. I am a fourth year PhD student at IIT Bombay, and I am a NPTEL TA for the course which is entitled as Principles of Organic Synthesis. And the course instructor is Professor T. Punyamurthy from IIT Guwahati. So, we have already done 3 weeks tutorials, and today we are going for the week 4 tutorial. So, let's start today's session. So, in today's session, we are going to discuss the lecture 7 and lecture 8, which is uploaded on YouTube by Punyamurthy sir. So, the lecture 7 and 8 are talking about the organolithium and organomagnesium reaction. So, the reaction which is involved in these two lectures are Grignard and organolithium reagents. So, today we are going to discuss these two reagents and question based on these two reagents. So, carbon ion. What is carbon ion? Have you ever think about what is carbon ion? So, carbon anion is a species or anion in which carbon has an unshared pair of electron and bear a negative charge. So, negative charge is present on carbon. So this negative charge is nothing but the pair of electron. All of you know that. So that's why I have written here unshared, means it is ready to pair, but currently it is unshared and not bonded. So pair of electron, okay, pair of electron is a carbon anion. So carbon anions are strong bases, and they are easily quenched by even a very weak acids like water, alcohols, amines, carboxylic acids, amide, and even a terminal alkynes also. So a limitation of utility is there. So always the negative charge or this pair of electron will uh, ready to form a bond with another electrophile to form a new carbon and different atom bond. So to get the stability, right? So that's why these are carbon ions are more reactive. So here you can see here alkyl lithium we have, and here we have amine, primary amine. So primary amine is a basic, right? It's a basic species which has a pK value of 40. So because these protons sorry, this is a basic species. So alkyl lithium, talking about the alkyl lithium, carbon has slightly partial negative charge and lithium has partial positive charge. And talking about their electronegativity, right? So lithium have electronegativity of 1 about 1, and this has something 2 point something, yeah, around this only, around 2. So you can see the more negative charge is on carbon side, so that's why. And the difference is also very high. So because of this difference, this bond is polar, right? And the negative charge will more stabilize on carbon, so it will act as a nucleophile, right? And nucleophile means carbon anion. It will attack on a this, it will take up this proton, attack on this primary amines hydrogen, because nitrogen is there, but these two protons are acidic, right? So it will take up this proton and it will form alkane, alkane, and the other species released in reaction is this salt, and this salt will be quenched by any other nucleophile, okay? So talking about the formation of organolithium and Grignard reagent, so here you can see that we have alkyl halide, right? Alkyl halide. So here we have al alkyl halide, and this halide can also be a chloride and iodide. Here we have taken bromide, right? Bromide. So when we add the lithium in this case, so lithium will replace this bromide. So lithium halogen exchange we call this one. So after the lithium halogen exchange, we are getting lithium, alkyl lithium, and the other lithium will bind with the bromide. Okay, so that's why two equivalent is required. So because lithium has only plus one valency, so that's why it can bind with only one species at a time. So that's why two equivalent is required. Got it? And talking about the Grignard reagent. So in Grignard reagent, you can see we have again alkane halide, alkyl halide, and in this alkyl halide, magnesium insertion is taking place. Magnesium is getting inserted. So all of you know that magnesium valency is 2, right? Magnesium has 2 valencies. So that's why it will get inserted between the alkyl and halogen bond. Between the alkyl and halogen bond. So both organolithium and Grignard reagents are very reactive nucleophiles and strong bases also. So we'll discuss the some more organometallic reagents here. So here, in summary, we know that Grignard reagents are strong nucleophile and strong bases, right? And will form carbon-carbon bond with electrophiles such as aldehyde, ketones, esters, and epoxide. So we have here addition of aldehyde and ketones. So suppose we have here aldehyde H. If H is there, that means it is aldehyde, and if R is there, that means it's ketone, alkyl group, right? So now we have added Grignard reagent on in aldehyde. What will happen? So all of you know that if we have alkyl halide, right? So this is the partial negative charge will shift here, and partial positive charge will be there on carbon atom. Why? Because bromide is an electronegative atom more than carbon. Carbon has less electronegativity compared to bromide. So if now this will attack this carbon now act as a electrophile, right? Electrophile. But talking about our MgBr, when we are making a Grignard reagent, now you can see that magnesium has less electronegativity compared to carbon, right? And bromide is also electronegative. So here, when this RMg bond breaking will takes place, the carbon will carry the negative charge. Carbon will carry the negative charge, right? And it will now act as a nucleophile. Nucleophile, right? So for this type of reaction, where we require nucleophilic attack, that time we need to make the R group as a nucleophile. So electrophile can't attack on carbonyl center because carbonyl center is always electrophilic. So that's why Grignard reagent uh, is used for nucleophilic addition of alkyl. Okay. So now all of you know that R minus will attack on carbonyl center here, and it will get open, right? So it will give you this as a product. Understood? So this secondary or tertiary alcohol, depending on the aldehyde and ketone, you will get here. Sorry, primary and secondary alcohol, depending on the aldehyde and ketone, you will get here. Okay. So new carbon-carbon bond formation is taking place. Which bond formation? R is getting bonded with this carbon atom, right? So this carbon-carbon new bond formation is taking place. Okay. Here I can show you this one. So this is the first example, addition to the aldehyde and ketone. Now the second example is double addition to ester. So suppose instead of the aldehyde and ketone we have ester, right? So in ester what will happen? We have ester and we have here RMgBr, right? So this will act as a nucleophile. Nucleophilic attack will take place to form a, sorry, here MgBr will bind over here and we will get OR. All of you know this one. Now after this one, what will happen next? So this lone pair will push here and this will knock out as a good leaving group. Okay, good leaving group. This OR minus is a good leaving group. And what we'll get here? O MgBr, right? Got it? After this one, what will happen next? Again, we have electrophilic center. So the another molecule of Grignard reagent will attack over here, right? And it will become ROH after workup. Okay, after workup it will become ROH. So this is the product we are getting in this case. So how many R group I have attached here? Sorry, I forget to write here. R. Okay. So we get tertiary alcohol. So in ester case, double addition will take place and it will give you a tertiary alcohol. And in case of halides also it will be the same. Suppose here we have acid chloride, correct? Suppose we have any halide group. Again, this is a good leaving group. It will act as a same, and after the elimination we will get the tertiary alcohol. So here again we have CC bond formation, but two new CC bond formation is taking place, right? Two new bond formation is taking place. And alcohol is formed here. Okay, functional group is getting changed from aldehyde or ketone carbonyl to alcohol, right? Now the third example is given here, addition to epoxides. So at least substituted carbon. So here when we have epoxide, so again nucleophilic attack will take place from which side, this or this. So remember this, always the less hindered phase is accessible for the Grignard region. So it will prefer to attack from the less hindered side, less substituted side. So opening will takes place like this way and it will give you a secondary alcohol. Okay. So least substituted carbon is a more preferable for Grignard reactions. Now the next one is addition to carbon dioxide to give the carboxylic acid. So suppose here we have CO2 and again this nucleophilic attack will take place here and it will get open, right? So it will give you a, here I am writing RCO minus, right? Correct? So it will give you a product this after workup. So again we'll get acid when the reaction will takes place with the CO2. CO2 addition will takes place. Okay. So Grignard reagents will also undergo fast protonation with alcohols and carboxylic acids to form the CH bond. So we'll discuss this reaction. Here we have Grignard reagent. Okay. So the reaction will takes place with acidic H plus proton or deuterium to give the alkanes and alkenes. So how it will go? So this will act as a base and it will trap the proton. It will abstract the proton. So RH bond formation will takes place and the byproduct will be here alkoxy magnesium bromide will be there. Okay. So these are the types of reaction done by Grignard reagent. So we'll discuss now questions. Okay. So let's start the first question. Predict the major product of the following reaction. Anyone? Just check the arrow. Here we have methyl magnesium bromide 2 equivalent and workup, that is a water. Proton source is here given, water. So now here at which center the nucleophile attack. So you can see here we have lactone, right? And this center is electrophilic. So the nucleophile will attack over here and it will give a intermediate here. O methyl, right? And here I am writing R because this long chain I am not writing because the changes and reaction is occurring at this place only. Okay. So after this one, what will happen? I have told you in ester case, lone pair will push over here and this will act as a good leaving group. This bond will get break. Okay. And it will give this as a intermediate. Got it? After getting this intermediate, what will be the next step? Again we are adding methyl magnesium bromide, correct? And this nucleophile will attack over this center again on ketone. So it will give a OMG, Br, Me and Me. Got it? And now the workup with water proton source is there. It will give OH, OH to methyl group. Got it? So which one is the correct answer? Option number 4. Got the mechanism? So I hope all of you understood. Now let's move to the next question. Here the major product of the following reaction is. So here again we have given a vinyl magnesium bromide, right, in THF at -40 degree. Again workup is given, water. So here we have starting material as a nitro compound, right? Nitro. So the mechanism it will follow here. I have written in this case. It will attack on nitro group because there is no carbonyl center is present in the substrate. So electrophilic center, which one is the electrophilic center? So this oxygen, because it is bonded with the nitrogen, so it will attack on the nucleophilic attack on will takes place on oxygen atom, right? And it will give the intermediate species like this one. After getting this intermediate, what will be the next thing? The lone pair will push here and it will eliminate as a good leaving group. Okay, it will act as a good leaving group and we will get here this as a leaving group and this nitrone as a intermediate. After getting this nitrone, again the other molecule of vinyl magnesium bromide will attack on the oxygen and this bond will get shifted over here. Okay, and it will give a intermediate like this. Okay, after getting this intermediate, what will happen next? 3 sigma tropic shift. So 1 2 3 and here 1 2 3. So in 3 sigma tropic shift, the 3 bond formation is taking place, new bond formation this one, and 1 bond is getting break. Okay, so after this rearrangement we will get intermediate this one, and after getting this one, it will at this now nitrogen, this nitrogen is nucleophilic, right? This is also like a Grignard reagent. Can you see here? So this is nucleophilic, right? So this new Grignard reagent, which is intramolecular only, it will attack on carbonyl center, and the oxygen, it will get open over here and form a 5-member ring. Okay, after this 5-member ring formation, the proton abstraction will take place from another molecule of the vinyl bromide, because it can act as a nucleophile as well as base. I told you in earlier only. Uh, Grignard reagent sometimes act as a base also. So it will abstract the proton and aromatization will takes place. So this imine will get converted to amine, indole, and after the indole formation, the water will protonation will takes place here, and water will eliminate as a good leaving group to give the corresponding indole, methyl substituted indole as a stable product. Because of aromatization, this water molecule will eliminated. Okay, double bond will come over here. So we will get a methyl substituted indole over here. So this is a tricky mechanism. You should practice this one. Okay. So the correct answer is indole. This one. Okay. Now let's move to the next question. Question number 3. The major product formed in the reaction given below. So here again we have given a phenyl magnesium bromide, phenyl Grignard, and instead of the other reagent, here copper bromide is added here, right? Copper bromide is given here. So how the reaction will take place? So first of all, you have to see that phenyl magnesium bromide and copper bromide is there in reaction. So they together mix together and they will form phenyl copper. Okay. MgBr2. Then this phenyl copper will further react with copper bromide. Phenyl magnesium bromide to form phenyl 2 copper magnesium bromide. Okay. So this is also the case in Gilman reagent. So if you will talk about Gilman reagent, Gilman reagent is nothing but this copper lithium. Okay. So like that it will form in Grignard also. So because it's a weak nucleophile, so weak and have you heard about soft and hard nucleophile? So weak nucleophile will attack on weak nucleophilic center. Okay. So it will attack on 1,4 center instead of 1,2. So in Grignard case we are getting 1,2 product, 1,2, right? So it will attack on 1,4. So whenever we have conjugated system and we are using copper with Grignard, that time 1,4 addition will takes place. So here we will get I will directly write the product here. Phenyl now talking about the option. So you can see in option number 1 and 2, phenyl is here given 1,4 addition, right? These two options are cancelled. Now between these two, which one is the correct one? Stereochemistry. Can you tell me the stereochemistry? So here you can see that talking about the stereochemistry, this phenyl group is on back side. So from back side it will create a hindrance, right? It will block the face, and so that's why the addi addition will takes place from the front side. So front attack will be favored, and we will get the option A as a correct option, because when the front attack will takes place, it will come on a wedge side, right? So our correct answer is this one. Got it? So now next question. The major product formed in the reaction given below is. So here you can see that we have active magnesium, CO2 and water. So here we have added a activated magnesium in the reaction. So what will happen first? Magnesium will get inserted between the carbon halogen bond, right? So we will form this Grignard reagent. Because I forgot to mention, these Grignard reagents are very reactive, and it can react with the moisture to get the quenched also. So that's why we have to make it in situ whenever we require. Most of the time we need to make it in situ, or we have to care very much for preventing this molecule to get the quench. Okay, so inert atmosphere is must for this Grignard reagent. So that's why in situ formation is preferable. So for in situ preparation, we are adding a magnesium in the same RB along with the solvent. Sometime ether, sometime THF is used depending on the substrate. Okay, so after getting this intermediate, this formation of the Grignard reagent, the CO2 is added. Now how it will react with CO2? This will act as a nucleophile, right? And it will give you a, and this species, I'm writing R. Okay, so it will take up the proton from water and it will give you a product. Okay, so the correct option is option number 3. Next question is to predict the major product of the following reaction. So here nitrile group is given, correct? Nitrile, and we have phenyl magnesium bromide on arrow and workup. So what will happen here? See here, the nucleophilic attack will takes place on a electrophilic center of nitrile group, that is carbon, this carbon. Okay, so the intermediate will get in this case is this one. After getting this intermediate, the protonation will takes place to give the ketamines, ketamines. Okay, after getting this ketamine, the workup will takes place, and followed by the hydrolysis will get the corresponding ketone. So after the hydrolysis we will get the corresponding ketone. So what is the correct option? Option number 3. This mechanism is also explained by very well by Professor Punyamurthy sir on YouTube. The video is available on YouTube. So please go and check all the examples he has shared. So you will get help to solve these questions. So next question is the product of the reaction is, we have given here vanillabamide, right? Here the vanillabamide is given, and we have methyl magnesium bromide on arrow, and again the acid and water workup, right? Workup condition. So H plus will come from here. So we have to solve the mechanism first. Here methyl magnesium bromide will attack on this center. Nucleophilic attack will takes place here and it will give the intermediate, this one, right? So after getting this one, the lone pair will push electron. So here protonation is taking place. After the protonation, lone pair will push electron over here and this will act as a good leaving group. Right? It will act as a good leaving group to give the corresponding ketone as a product. So the correct option is option number correct. Next is the predict the major product of the following reaction. So the organolithium reagent is given on arrow. Organolithium means organic and lithium group is there. Lithium, organic lithium compound, right? So organolithium is always giving a 1,2 product, as I told you earlier, like a Grignard only. But the electronegativity is high in this case for the nucleophile. Why? Because lithium is has a more positive charge. So higher the positive charge here, the negative charge will get higher in this side. So nucleophile will be more nucleophilic. Sorry, electronegativity will be increased here. Okay. So talking about the Grignard, it has 1.3, right? And in lithium it has 1. So it is less electronegativity than the magnesium one. So the nucleophilicity will get increased here, right? Like this way. So that's why here organolithium is used. So methyl lithium will attack on a carbonyl center. Where is the carbonyl center? We have here aldehyde, right? So it will attack on aldehyde and will give the alcohol. So here we are getting a mixture of two alcohol because this is the chiral center. Chiral center is given here, so that's why stereochemistry matters a lot in this case. So we will solve it by Falkenhayn model. So what you have to do in Falkenhayn model? First of all, you have to make a perpendicular. You have to write the molecule in a Newman projection. So in Newman projection, write a carbonyl group perpendicular to the plane. Okay. So vertically you have to write this thing. Now the bulkier group will come on one side. Either you can write this side. So suppose I am looking the molecule from this way, right? So this is a front carbon number 1, this is 2, this is carbon number 1 and back side 1 is 2. Okay, so carbonyl center I have written this way. So bulkier group will be on perpendicular to this carbonyl center. So which one is the bulkier group? All of you know that NBN2, right? And BN2 will be perpendicular to this one. Now we have to set these two groups. How we can set? So remember that hindrance should be less. So always the medium size group will be on carbonyl side. Always medium size group will come over here and small group will be here. Okay. So to avoid the hindrance. Okay. After this one, the attack will takes place from which side? So here large group is there. So here it is not possible. So always the attack will takes place from this side. Nucleophilic attack. So when the nucleophilic attack will takes place, the molecule will become like this one. Correct? you can see that if you will rotate it like a Schauer form, if you will write in a Schauer's form, from Newman to Schauer conversion, you should know this one. So we have this NBN is backsides, right? So just rotate the front carbon. This nucleophile is methyl. I am writing here methyl to avoid the confusion. Okay, nucleophile, right? Now I will keep both the methyl group perpendicular to each other, right? So now it is ortho to each other, right? Right now these are ortho to each other. So how much I have to rotate this to get the anti? 120 degree, right? So 120 degree rotation of front carbon. I will do front carbon. Okay. So first of all, I will write here the back carbon will remain as it is because I am rotating the front one only. And BN2, right? And I am rotating this one by 120. The methyl group will come over here. OH and H. This will come here, it will go here, and it will go here like this. Got it? So after getting this one, you can see that just imagine molecule from this side. So methyl is upside, right? And this methyl is downside. So I have to draw this way. Methyl is here, right? And the NBN2 group is coming towards ourselves. That means it is on wedge. And this H is backside, right? And talking about this one, OH is going back. And sorry for the interruption. Due to the technical error, the PC and recording gets stopped. So let's start in continuation. I have already explained these questions. Yeah. Zimmermann Falkenhayn model I have explained. So let's move to the next question quickly. So the major product of the following reaction is. So here again on arrow, the butyl magnesium bromide is given. And we have here carbonyl center, this one. So how the mechanism will go here? You can see here. This butyl magnesium bromide will attack on the carbonyl center and it will give you a secondary alcohol. So as you can see here, we have bulky group O mom on front side, wedge side, right? So that's why the front side is blocked by this group. So the attack will be preferred from the back side. So that's why butyl group will attack from back side. It should give this product. But here you have to consider one more thing, hydrogen bonding effect. Which is very much important in this type of reaction. So you can see here the intermediate or transition state is given here. So always we have to make the carbonyl group vertical to the plane, right, perpendicular. And we have to write the bulky group on one side and the medium group on carbonyl side and small group on hydrogen side, right? This is the way to write the in transition state. So now the bulkier group, bigger group will attack from this side only. Remember, right? So because if in earlier case, if you remember, I have made the group like this way. Here I have added the larger group and here medium and here small, correct? So if we will make this way, so the attack should be happen from this side, right? So if I will write the opposite case, here I am writing perpendicular, so that time we have to place the small group here and medium group here. So they both will give the same product but with different transition state, right? So but in this case I am here we are writing this way, small group should